Welcome to Mobile Math lessons on the go. Today's learning goal, by the end of this lesson, I should be able to add positive and negative numbers together without the use of a calculator. So let's get right into it. We'll start with something called the zero principle. And the zero principle states that a positive and a negative value of the same magnitude or size cancel each other out. So if I have a positive 5 and a negative 5, and when I combine those lead to a 0. If I have a negative 100 and a positive 100, again, if I were to combine those would lead to a 0. So we're going to use something called integer chips, two colored counters, and a little bit of a T-chart here. So I'm going to start with A here, which is would like to represent 0. So without any chips being placed below this horizontal line, that would be a 0. But I could also represent 0 this way. If I bring one positive and one negative chip down, this would also be a 0. As long as I have even number of positive and negative chips, we consider these to 0 off, so I can express 0 in different ways. For B, or if I want to show positive 3, I could drag down 3 positive chips, and this would represent a positive 3 just the way it is. Or I can actually bring down some 0 pairs, is what we call them. So one positive and one negative on each side. And so when we're looking at these bottom values here, these all 0 off, but we can still have them there if we need them. So this here would be the positive 3. C, if I want to express negative 2, I can bring down 2 negatives. And that would be one way to express a negative 2, just like that. If it'll move with me here, there we go. Or I could use some 0 pairs as well, and as long as they're on the page, these bottom two values 0 off, and I am left with my negative 2 right here. So that's how we use integer chips with a little bit of a table. And we're going to be using that throughout the next couple examples. So let's get started. So I'm going to add a couple of values together just to show you how the integer chips work. So the first one is 3 plus 2, and I'm sure you could probably do that in your head and be quite confident in the answer, but how I'm going to say is I have 3 positive chips plus 2 more positive chips. So you'll notice up here I have some 0 pairs. That's okay, they can just sit there. Down here I have 3, so I'm going to drag down 2 more positive chips. 1, 2, and we get the answer that we would expect, a positive 5. So the answer up here is positive 5. If I come over to part B, I have 6 plus negative 4, or 6 positive chips plus 4 negative chips. So you can see I have an unbalanced value of 6 down here. So I'm going to drag down 4 negative chips. And there's 2, if it moves along here eventually, 3, and finally the fourth one. There it is. And when we look at all of these all 0 off, and I am left with an unbalanced value of positive 2. For part C, I have 3 plus negative 4, so I'm going to take 3 positive chips plus 4 negative chips. So let's drag 4 negative chips down here. So there's 1, 2, 3, and finally 4. So if I check what I have to 0 off, these all cancel, cancel, cancel. So I am left with 1 unbalanced negative chip. So the answer here is negative 1. We'll get a little bit larger. We'll use more than one number. So for part A, I'm going to have negative 3 plus negative 2 plus 1. How that reads is 3 negative chips plus 2 more negative chips plus 1 positive chip. So if I have my negative 3 already down here, I'm going to drag down 2 more negatives. There's 1, there's 2. Then I'm going to drag down 1 positive chip. And then I look to see what zeroes out. So these are all gone, and I count up what I have left over. I have an unbalanced negative 4. For part B, I have 4 plus negative 4 plus negative 2, so that's 4 positives plus 4 negative chips plus 2 more negative chips. So if I drag down 4 negatives here, there's 1, 2, come on, 3, 4, so there's the 4 negative chips. Now it says bring down 2 more negative chips, and I may not have the room. Oh, it's going to be close. And there's my 2 more negative chips. Come on. Oops, I lost them. Come on, let's go right down there. There you are. And then I'm going to 0 off. And we should notice that we are left over 2 negative chips, and that would be our final answer of -2. So sometimes, though, when we get larger numbers, the integer chip model doesn't work so well. So we can modify it, or we could use the number model. So I'll show you how we modify the integer chip model. I have -13 plus 15. So I might write -13 as a group of 10 and a group of 3. And then if I have to add 15 positive chips, I might write that as a group of 10 positives and a group of 5 positives. And what I can see is that these will cancel off. And now I could break this down a little further. I could change this into an integer chip model where maybe I have 5 little chips on each side and then 3 on each side, and then I just 0 them off. And I have a final value of +2. And that would be a completely acceptable way to use both the integer chips and a bit of a number model combined together for this type of problem where the numbers are a little larger. If we do a number model, I might break the -13 down into a -3 plus a -10, and I might break the 15 down into a +10 and a +5. And again, I could see the same effect where the negative and the positive will cancel. I will be left with a -3 plus a +5. And hopefully I'm getting comfortable enough that I can see that that is a +2 as a final answer. So there's more than one way to solve these problems. Don't feel you must use one particular way explicitly. You can use whatever you feel is necessary to find the right answer. So we definitely aren't going to use chips for 55 plus 48. But what I might start to do is break down the numbers. I might think a little further ahead and say, well, 55 is the same as a 40, a 10, and a 5. And -48 would be the same as a 40 and an 8. And right away I could see those 40s cancel. They zeroed out. So now I just have to work with the next parts. So I might change my 10. Let's move that 5 down. I might change my 10 into an 8 and a 2. And then I could see I could 0 these pieces off as well. And now I'm left with an unbalanced amount of 7 positive chips. Same sort of idea on the number model, only instead of writing it in columns, we might break it up into a 50 plus a 5 plus a -40 plus a -8. And it might take us a line or two to figure out how to break these down so that they match up nicely. So I'll continue to break the 50 down. And I'll get to my -40. And then I might even break the -8 right down right now. Or I'll leave it, one or the other. So I can see the 40 and the -40 cancel. I'll break my -10 down into an 8 plus 2. There's the +5 still. And I still have this -8 at the end. And then I could cancel the 8 and the -8. And again, I'm left with +7. So again, there's lots of different ways to approach these problems. You need to find ways that work for you personally. So let's pause the video for a second here. So just hit pause, and I'll give you a chance to try these two, and then I'll take them up fairly quickly. Okay, welcome back. So the first one here I'm going to use an integer chip model for because the numbers are a little smaller, and I feel confident that I can do that relatively quickly. So I'm going to start with -4. So you can see that that's already on my table. The next part says add 3 positive chips. So I'm going to drag up 3 positive chips that I already had locked together. And then the final piece is add 7 negative chips. So if I bring up 7 negative chips just like that, I can see what zeroes out. So this positive and this negative will cancel, cancel, and cancel. And then I just have to count up this amount. And if I count that up, I should find I have -8 chips. Okay, over here on the -58 plus 26, again, I might break this up into smaller numbers to help myself out. 26 I can break up into a 20 and a 6. 58 I might break up into 20 negatives, 30 negatives. I'm going to reach forward a little bit here. and break the 8 up into, or the 8 into a 6 and a 2, because I know what I want to do. I know that I want to have this 20 and this 20 cancel. I know I'm going to have this 6 and this 6 cancel. And by the time I'm done, I'm left with 32 unbalanced negative chips, or just numbers in this case. So that is one way, or two ways I should say, to work with both positive and negative numbers in the same question, whether they're small or large. You have a number model, you have an integer chip model, and we can kind of use a hybrid or mix in between. Thank you for watching, so please feel free to watch again and pause where you may have had difficulties, and good luck in your future math problems.